Hi, this is Stephen Haynes, and I'll be presenting Rural Water Supply in the 21st Century, Part 4, Improving Rural Water Supplies. In Part 4 of this program, we'll cover how to identify your existing operational limits, some methods of resolving those operational limits. We're going to present or introduce the concept of concentrating water up front. We're going to introduce that because it helps you to maximize flow capacity, minimizes the potential for flow interruptions, it maximizes the effectiveness of what you can do early on in the fireground when other resources are delayed or don't respond. So the first step in developing any kind of improvement program is you need to figure out what's broken and how badly it's broken. So what we're going to do is go outline a 7 or 8 step process for you. First, we want to sit down and take an honest look at our workday attendance records, Monday through Friday, say 8 to 4 o'clock p.m. Look at the average number of people that responded to your calls, both in your fire department and the other responding fire departments, and try to figure out about when those folks arrived, what vehicles they arrived on. So how many people did you have on the fire ground 5 minutes after the first truck arrived, 10 minutes after the first truck arrived, and 20 minutes. Then take a look at the typical running order for you and your mutual aid partners to figure out what trucks showed up on the fire ground and in what order. As you do that, you're going to want to add up the gallons of water that came with each truck. And once again, you want to try and break that into a 5-minute, 10-minute, and a 20-minute window to keep track of how much water is getting on the fire ground and how quickly. With our manpower count in hand, what we're going to do is we're going to take a look at those 5, 10, and 20-minute intervals. We're going to take the number of people available in each interval and we're going to divide it by 2. We're going to take half those people and assume that they're available for handling hose lines. The other half are going to be tied up driving trucks in the command structure, ladders, moving hose around, all kinds of things. Anything it takes to support the folks that are on the interior hose lines. Once we know how many hose lines we can put into service, we're going to take a look at our typical fire attack and what our typical hose line operations are. And you're going to divide the volume of water available during that time period by the GPM of the hose lines you would normally be flowing to determine how long could you sustain that flow. And we'll show you how to do that in a spreadsheet that follows. And then the last part of that is, hey, we're going to take a look at the NFPA or the NFA quick formula. And we're going to see how much knockdown power we're getting out of this typical hose line operation that we're trying to start our firefighting with. The next couple slides summarize a typical water supply analysis. They're done in a spreadsheet type format. I've kept them pretty simple, but they do get busy. So what I'd like to suggest is that as you go through this program, pause when you get to the slide, look over the slide, then start the program or start the presentation back up again to listen to the discussion. If you do that with each and every one of them, you'll get a lot more out of the slide material. So in this analysis, the apparatus arrival order shown in this column, the number of firefighters available at our time periods is shown. As you can see, it's pretty thin. We start out with 4 guys in the first 5 minutes, and we only got 10 in the 10 to 20 minute period. Because of that, we can't get a whole lot of hose lines in play. They're using 1 3/4 at 200 gallon a minute. So we're stuck with a 200 gallon a minute fire ground using 1 3/4 hose lines for the first 5 to 10 minutes of the fire. We've got relatively small tanks on the engine. We've got a 500 gallon engine and a 400 gallon quint. So in theory, we can only sustain this 200 gallon minute flow continuously for 4.5 minutes. It's kind of saying we got a pretty good chance that we're going to run out of water before engine 1, 2, or tanker 5 arrive on the fire ground. So one of the things we need to do before we really start looking at that analysis closer is we need to account for stranded water. What stranded water is? This is the water that's left in the hose lines when the pumps run dry. So all our attack lines, all our supply lines, there's going to be water laying in these lines that really becomes useless. Based on this department's SOPs, they're typically using 1 3/4 attack lines, 4-inch hose, and they tend to roll right into a drop tank operation or folding tank operation. If you add all these numbers together in this first alarm assignment, there's going to be about 560 gallons of water in that assignment that are going to be lost to the fire ground that aren't operational. It's just a fact of life. You just can't use all the water, but you do want to minimize how much water you are leaving stranded in the hose lines. In this table here, we've made our adjustment for stranded water. We've taken that out of our available water count. Our flow rates and our manpower have remained the same. The biggest thing where you notice a change is in this first 5 minutes of firefighting, that we're now down to just a hair over 4 minutes of water being available. So now, the probability of us running out of water before engine 1, 2, or tanker 5 arrive has gotten more pronounced. We're still only able to handle about a quarter of a building being involved in fire. And you really got to think about this. Why would you want to run a Quint with 400 gallons of water where you've got no water supply? What's the benefit of having advanced truck company operations available when you don't have any water to support basic engine company operations? We'll talk about that a little more later. So there's a couple things we can take away from the previous slide, and some questions that it raises actually. Station 1 in this case serves both a hydranted area and a non-hydranted area, and they're running the same assignment in both areas. You got to wonder, hey, is engine 1 with the smaller tank running first just because it's the newer truck that everybody likes? So that's one question. Why is an area with a small water tank rolling before our water supply pieces? Advanced truck company operations don't do us any good if we don't have the water supply to support the basic engine company operations that we need. The other thing too is this department's standard procedure has them rolling into a folding tank operation very quickly. If you think about it, if you've only got 10 people on the fire grounds to operate your trucks, support your hand lines, drag your hand lines, there's really not many people to handle folding tanks. Folding tanks are a pretty manpower intensive operation, no matter how you have them set up on the side of your tanker. This initial alarm assignment, especially the water available in the first 5 minutes, is pretty dicey even for a room and contents fire. And when I say it's dicey, it's what if something goes wrong? How are we going to protect our own? If somebody gets lost, separated from their hose line, somebody gets hurt, if we have an emergency in that building, we've got no extra water available to deal with this issue. I think that's something that we really want to take with us from that analysis. So what I'm going to propose here is a quick fix for our situation. The first thing we're going to do is change the running orders at Station 1 and 5. We want to see the engine with the large tank roll first, followed by the tanker, and then they can bring anything out the fire ground they want after that point. And we want to change our SOPs around for what the apparatus are going to do when they get to the fire ground. That we want to start concentrating the water up front. So the first engine on scene is going to go into service as our attack engine, which is normal. The second engine is going to lay the line up the driveway if it happens to be a long driveway. And when he gets there, he's going to give his tank water to that first engine, and he's going to give that supply line that he just laid to the first engine. Then the first tanker, when it arrives, it's going to charge that supply line. The second tanker can then either give its water to that first tanker, or if we put a gated Y or other device on the end of that supply line, they can tap right into that supply line and start feeding as soon as the first tanker starts running out of water. And then from there on, every additional truck or tanker that arrives gives its water to the front of the fire ground. It always gets moved up through that supply line. The whole objective here is we got to keep that hose line that's in service continuously in service with no interruption of flow, and increase our ability to put bigger and more hose lines into service as quickly as we can. So I've updated the table to reflect the new running order coming out of Stations 1 and 5. And the biggest thing you're going to notice right here is we went from only having 4 minutes of water supply available to almost 10 minutes of water supply. So that's basically overlapping the next 5-minute time period that we were concerned about. So we've quite eliminated that issue or that concern about running out of water before the tankers get there. So it's a big safety boost. Now we've got the water to deal with an emergency involving our crews in that building. It just really opens our opportunities up. The other thing it does too is if we need to, we could pull a larger hose line or a master stream out to knock this fire down before we move into a smaller hose line attack, because we now have the volume of water available to support that. If we take a quicker look at this quick fix, there's a couple things that stand out here. First, we now have the ability to put a 300 gallon a minute or larger small master stream into operation, which we didn't have before. So we have the ability to knock down quite a bit of fire from the outside of the building before we go into service inside the building with our smaller hand lines. And actually, once the tankers are on scene, which is within 10 minutes, we've got the ability to generate flow rates of up to 600, 800 gallon a minute, which is enough to knock down a pretty significant amount of fire. Room and contents fire from a water supply perspective at this point really become a cakewalk. That the water supply is the least of our worries instead of being all of our worries. Okay, to start summarizing, there's a couple fundamental concepts we want to take away from this analysis. First, your SOPs and your running order for your apparatus needs to be different for your non-hydranted areas than it is in your hydranted areas. We need to set up our running orders and our SOPs so that we're concentrating as much water as possible up front as quickly as possible. Remember, the whole name of the game here is get the water in front of the building. It makes it safer for our firefighters, and it makes it more probable that we're going to have an effective fire attack. Vehicles with small tanks have no place early on in the assignment, and you need to focus on basic engine company and truck company operations. It's nice to have that ladder truck so everybody can see it, but in all honesty, if you don't have the water to support basic engine company operations, the ladder truck is a waste. And I got a couple advanced concepts I'd like to talk about too. Tankers need to have high capacity pumps on them for nursing operations. It's much more efficient to nurse from a tanker from a manpower perspective and a time perspective than it is to try to set up a folding tank operation. Folding tanks are great for drills, long duration fires, and big water shows. But other than that, leave them on the side of the tanker. They don't belong on the ground in front of a small structure fire. Always, always, always push your water and hoard it as close to the fire ground as possible. Remember, this is a safety issue. We need to have water available to deal with problems if one of our members gets into trouble. As a side benefit, it'll also make us more successful in putting the house fire out. Long hose lays require trucks with big tanks. In our running order, the whole idea there is that we're always feeding that long hose lay up the driveway with a tanker. So we can afford to lose 300, 400, 500 gallons of water in the hose because there's a lot of water on board the tank. The bigger the tank on a pumper, the better. Just keep in mind that the pumper can't get too big for your geographical constraints. Here in the Northeast, I am not a big fan of engine tanks. The rural property in our neck of the woods is down a small, windy, one-lane driveway coming off of a 2-lane road with no shoulders and probably ditches on the side. Not conducive to big, long tandem axle trucks. I really firmly believe that small monitors with shutoff valves should be on every first out structural engine. They give you so much ability to put a very large amount of water on the fire very quickly and to shut it down very quickly so that you don't waste water. That concludes part 4 of our series. In part 5, we're going to start talking more about tactics and equipment. Particularly in part 5, we're going to look at concentrating the water up front and the tactics around that. I hope you found this presentation useful, and I look forward to hearing any of your feedback. All my contact information is listed below. Take care.